Every year, the global wood industry processes more than 4 billion cubic meters of timber, producing enormous volumes of lumber for construction, furniture, and paper. In fact, in modern wood processing industries, more than 95% of wood waste is reused or recycled. What once looked like useless dust is now turned into energy, engineered wood, fuel pellets, fertilizers, and even advanced biomaterials. Today, we're stepping inside the supergiant sawdust recycling industry, where mountains of wood waste are transformed into valuable resources that power factories, heat homes, and build new products across the world. Before we dive in, don't forget to like, subscribe, and turn on the notification bell so you never miss our deep dive documentaries into the hidden industries that power the modern world. To understand this industry, we first need to understand where all that sawdust comes from. In a typical sawmill, only about 50 to 60% of a log becomes finished lumber. The rest turns into byproducts: sawdust from cutting, wood chips from trimming, bark removed from logs, and small offcuts that cannot be turned into boards. Multiply this by thousands of sawmills and furniture factories operating every day, and the scale becomes enormous. A single large sawmill can generate 200 to 400 tons of wood residues every day. Across the United States and Canada alone, the wood industry produces tens of millions of tons of sawdust and wood chips each year. Instead of throwing this material away, modern facilities capture it using powerful extraction systems. Another rapidly growing sector uses sawdust to produce wood pellets, one of the fastest growing renewable energy fuels in the world. Wood pellets are small cylindrical fuel units made by compressing dry sawdust under extremely high pressure. The process begins by grinding wood waste into uniform particles. The material is then forced through metal dies in powerful pellet mills. As the sawdust passes through the dies, friction generates heat that softens natural lignin in the wood. This lignin acts as a natural glue, binding the particles together without additional chemicals. The pellets emerge as dense cylinders roughly the size of a pencil eraser. After cooling and screening, they are ready for use as fuel. Wood pellets are incredibly energy dense and burn efficiently, producing far less smoke and ash than raw wood. Because they are made from recycled sawdust, they represent a renewable energy source that reduces dependence on fossil fuels. Today, the global pellet industry produces more than 40 million tons of pellets every year, and demand continues to grow as countries search for cleaner energy alternatives. In many regions, sawdust also becomes the fuel that powers the very factories that produce it. Biomass boilers use wood waste to generate heat and steam for industrial processes. Inside these systems, conveyor belts feed sawdust into combustion chambers where it burns at high temperatures. The heat produces steam that drives turbines or heats kilns used for drying lumber. Some sawmills generate enough electricity from their wood waste to power entire operations and even supply excess energy to local grids. Another major destination for sawdust is agriculture. Farmers have long used wood shavings and sawdust as animal bedding because the material is soft, absorbent, and inexpensive. Dairy farms, horse stables, and poultry operations rely on these materials to keep animals dry and comfortable. After use, the bedding is often composted and returned to fields as organic fertilizer, completing a natural recycling cycle. Wood chips and bark, meanwhile, are widely used in landscaping and soil improvement. Municipal recycling programs collect tree trimmings and wood debris from cities, grind them into mulch, and distribute the material for use in parks, gardens, and erosion control projects. Mulch helps retain soil moisture, regulate temperature, and prevent weeds from growing. This simple use of recycled wood waste plays a surprisingly important role in urban environmental management. In recent years, scientists have discovered even more innovative uses for sawdust. Researchers are developing biomaterials that transform wood waste into high-performance products. One example is wood plastic composite, a material created by combining recycled wood fibers with recycled plastics. These composites are used to manufacture outdoor decking, fences, and construction materials that are durable and resistant to moisture. Another emerging technology converts sawdust into biochar, a carbon-rich material produced through controlled heating in low-oxygen environments. Biochar can improve soil fertility and capture carbon, helping reduce greenhouse gas emissions. Other experiments are exploring how wood fibers can be used to create biodegradable plastics, insulation materials, and even advanced textiles. The reason sawdust can be recycled into so many products lies in the unique structure of wood itself. Wood fibers are composed primarily of cellulose, hemicellulose, and lignin, natural polymers that provide strength and flexibility. These fibers retain their useful properties even after the wood is cut, ground, or processed. This makes wood waste one of the most versatile recyclable materials available. Behind the scenes of this industry are massive logistics networks that move wood residues from mills to recycling facilities. Conveyor belts hundreds of meters long carry sawdust between processing stages. Front-end loaders move giant piles of wood chips across storage yards. Automated systems monitor moisture content, particle size, and energy output to ensure consistent quality. Some of the largest wood recycling plants operate around the clock, processing thousands of tons of material every day. Giant hammer mills shred wood waste into uniform particles. Magnetic separators remove stray metal fragments like nails or screws. Screening machines sort particles by size, directing them toward pellet production, engineered wood manufacturing, or energy generation. What makes the sawdust recycling industry particularly remarkable is its efficiency. In many modern sawmills, nearly every part of a tree is used. High-quality lumber becomes building materials. Smaller pieces become furniture components. Wood chips become paper pulp. Bark becomes mulch. Sawdust becomes pellets, boards, or biomaterials. Very little goes to waste. This efficiency reflects a long history of innovation in the forestry sector. In the early days of industrial logging, sawdust was often considered a nuisance. Sawmills dumped it into rivers or burned it in open piles. Over time, environmental concerns and rising resource costs forced the industry to find better solutions. By the late 20th century, wood waste had become too valuable to ignore. Today, the sawdust recycling economy supports thousands of jobs and generates billions of dollars in economic activity. It also helps reduce pressure on forests by ensuring that harvested trees are used as efficiently as possible. By transforming waste into resources, this industry demonstrates how circular economies can work in practice. The next time you see a piece of furniture, a bag of wood pellets, or even a landscaped garden bed, there is a good chance that the material began as sawdust. What once looked like nothing more than dust from a saw blade is now an essential raw material powering industries around the world. From giant sawmills to advanced recycling plants, the journey of sawdust shows how innovation can turn waste into opportunity. In the supergiant sawdust recycling industry, mountains of wood dust are quietly transformed into energy, materials, and sustainable solutions that help power the modern world. If you enjoyed this deep dive into the hidden world of wood recycling, make sure to like, subscribe, and hit the notification bell so you never miss our next journey into the incredible industries that shape the materials around us. Thanks for watching, and stay curious. With more than 20 million mattresses discarded every single year, the United States faces a massive waste problem most people never think about. Old mattresses are bulky, heavy, and nearly impossible to compact. They clog landfills, jam waste equipment, and consume enormous amounts of space. In fact, a single mattress can take up as much landfill volume as dozens of household trash bags. But here's the part very few people know. In America, mattresses are no longer just trash. They are a valuable source of steel, foam, fiber, and fabric. And this has created a massive hidden industry dedicated to taking mattresses apart piece by piece. Mattresses weren't always a recycling problem. For most of history, mattresses were simple: straw, wool, cotton, or horsehair stuffed into fabric shells. When they wore out, they decomposed naturally. But the modern mattress changed everything. Today's mattresses are complex industrial products: steel springs, high-density polyurethane foam, memory foam layers, synthetic fibers, fire-retardant barriers, fabrics engineered for durability. A single mattress can contain up to 70% steel by weight, along with multiple layers of petroleum-based materials that do not break down naturally. As mattress consumption increased, disposal became a crisis. Landfills filled with bulky mattresses that refused to compress. Waste facilities struggled as steel springs tangled machinery. Cities faced rising disposal costs. Something had to change. That change came through regulation and economics. Several U.S. states introduced extended producer responsibility laws, requiring mattress manufacturers and retailers to fund recycling programs. Instead of dumping mattresses, they would now be collected, dismantled, and recycled. This legal shift gave birth to one of the most unusual recycling industries in the country. The journey of a recycled mattress begins far from the recycling plant. It starts in bedrooms, hotels, dormitories, hospitals, and apartment buildings across the nation. When a mattress reaches the end of its usable life, it is removed during renovations, upgrades, or replacements. Retailers often offer mattress take-back services. Municipal waste programs collect discarded mattresses separately. Hotels replace hundreds at a time. Universities clear out entire dorm buildings in a single week. Each of these locations feeds into the recycling network. Trucks designed specifically for bulky waste collect the mattresses and transport them to regional recycling plants. Some facilities handle thousands of mattresses per day, stacking them in towering piles that stretch across industrial yards. These mountains of mattresses are not chaos, they are inventory. Once inside the plant, the real work begins. Unlike paper or plastic recycling, mattress recycling is not automated melting or shredding, it is industrial disassembly, a controlled, methodical teardown of a complex product. Workers wearing gloves, protective sleeves, and safety glasses move mattresses onto processing tables or conveyor lines. The first step is opening the mattress shell. Using industrial cutting tools, workers slice through thick fabric and fire-resistant layers, peeling back the outer casing like skin. Immediately, the inner materials are exposed. Foam layers, cotton batting, synthetic fibers, and padding spill outward. These materials are removed by hand and sorted into dedicated streams. Foam goes one direction, fiber another, fabric another. Next comes the steel core, the most valuable component. Inside almost every traditional mattress is a dense network of steel springs or coils. These steel frames are heavy, rigid, and extremely durable. Workers cut and separate the steel structures from the remaining materials. In some plants, hydraulic shears and automated cutters assist with this stage, snapping steel coils into manageable sections. The speed is impressive. An experienced worker can dismantle a mattress in just a few minutes. Multiply that by dozens of workers on multiple lines, and the scale becomes clear. Large plants process tens of thousands of mattresses every week. Once separated, each material enters its own recycling pathway. The steel is compacted into dense bundles and shipped to scrap metal processors. There, it will be melted down and reused in construction steel, automotive parts, appliances, or even new mattress springs. This steel recovery alone prevents hundreds of thousands of tons of metal from being mined each year. Foam is the next major stream. Mattress foam is shredded into small pieces using industrial grinders. These foam flakes are compressed into large bales or processed further, depending on demand. Recycled foam is used in carpet padding, gym mats, soundproofing materials, furniture cushioning, and insulation products. What once supported someone's sleep now supports buildings, vehicles, and athletic facilities. Fiber materials, including cotton and synthetic blends, are cleaned and repurposed. Some become industrial padding, others are used as insulation or filtration material. Even mattress fabric finds new life as wiping cloths or filler material. Nothing happens by accident. Every step is optimized for recovery. Recycling plants aim to reclaim 80 to 90% of every mattress. Very little ends up as waste. As materials flow through the plant, logistics move just as fast. Forklifts shuttle bales of steel, foam, and fiber to loading docks. Trucks arrive and depart continuously, feeding downstream industries. This is not a slow, experimental process. It is a full-scale industrial operation. Technology plays a growing role. Some facilities now use automated conveyors to feed mattresses into disassembly zones. Others deploy mechanical cutters to reduce labor strain. Tracking systems record how many mattresses are processed, how much material is recovered, and where it goes. Every mattress is accounted for. The environmental impact is enormous. Recycling a single mattress saves landfill space equivalent to dozens of trash bags. It reduces demand for virgin steel and petroleum-based foam. It cuts greenhouse gas emissions associated with mining, refining, and manufacturing. In states with mandatory recycling, landfill pressure has dropped dramatically. But mattress recycling is not just about the environment. It is also about economics. Recovered steel and foam have real market value. Recycling creates jobs in collection, processing, transportation, and manufacturing. Entire regional economies now depend on this once unthinkable industry. What makes mattress recycling remarkable is how invisible it is. Consumers replace a mattress and never think about it again. They don't see the dismantling tables, the grinders, the steel bundles, or the foam bales. Yet this hidden system operates daily, quietly preventing a waste crisis, and the scale continues to grow. As populations increase and replacement cycles shorten, more mattresses enter the system every year. Recycling plants expand. New technologies emerge. What was once considered impossible waste is now a predictable material stream. So the next time you lie down on a mattress, remember its future. Remember that one day, it will not simply be thrown away. It will be taken apart, piece by piece, by a massive industrial network designed to recover value from what others see as garbage. If you enjoyed this journey into one of the most surprising hidden industries in America, make sure to like, subscribe, and hit the notification bell so you never miss our next deep dive into the systems that quietly keep the modern world moving. Thanks for watching.
Every year, coal-fired power plants generate tens of millions of tons of ash, a gray powder so fine it can float like smoke, yet heavy enough to bury entire landscapes if left unmanaged. For decades, this material, known as fly ash, was considered a dangerous waste product, stored in massive ponds and landfills that stretched for miles.
But today, a quiet industrial revolution is turning this environmental problem into one of the most valuable construction resources on Earth. Instead of being discarded, fly ash is captured, processed, and transformed into concrete, bricks, and infrastructure that literally builds modern cities. Before we step inside this super giant recycling process, don't forget to like, subscribe, and turn on notifications so you never miss our deep dives into the hidden industries shaping the world around us. The story begins inside a coal power plant, where pulverized coal is burned at temperatures exceeding 1,400 degrees Celsius.